Hello, I'm Jaime Alvos. I'm a senior here at Fitchburg State, majoring in electronics engineering technology.
Hi, my name is Daniel Grosky. I am a senior also at Fitchburg State University, and my major is engineering technology. So, for our project, we decided to create a smart planner with remote monitoring and solar power. Now, the idea behind this is plant care is something that many people have to deal with on a day-to-day basis. So any way you can make a day-to-day routine somewhat easier is always going to be beneficial. So we designed a system that will be self-monitoring, and it will be able to run a continuous loop, collect data from sensors that we implemented into it, and then make changes accordingly.
And some of the material sensors that we use are the soil moisture sensor, the water level sensor. We use the water pump to deliver water, 3D printed enclosure that we made in CAD, and we use a potentiometer and LCD display that both work together. And we use a couple LEDs. We use an Arduino Uno microcontroller to control the whole thing, battery pack and solar panels, and charge controller. So if we look up in figure 1, so right here is the microcontroller that controls the whole thing, and it's connected to, again, the couple sensors that we used, the soil moisture sensor and the water level sensor. One measures the water in the tank that we have filled with water, and it will turn on or off the LED depending on how much water is left. The other one is a soil moisture sensor, which measures the amount of moisture in the soil. And if there's too little moisture, then the pump would start to deliver water. And in the next figure, we have the 3D printed enclosure that we made in CAD and we printed at our houses.
So our next figure is a double picture. The first one describes the app. So we also developed an app that will connect to this device via Bluetooth. The app is a way where you can read off the data the sensors are collecting in real time. So here you can see humidity and temperature are displayed. Humidity is in percentage and temperature is in Celsius, though those things can change. Also, at the bottom where you see the ear diagram, if you click that, it will read off the data that's collecting to you, or you can shake your phone and it will do the same thing. Our next part of that figure 3 is our solar panel. You can see in the top left of that picture is connected to a regulator. This is just going to regulate the voltage so the desired output is being output. And below that, you can see in figure 4 that is just a diagram using a PV system. That has to do with the Fitchburg State area. You can see in the left-hand side is both a north and south, north and west, and it is just showing the tilt versus the azimuth. It is a full year diagram, so there are days throughout every month of the year, and it's just showing that where the sun is with respect to that time, and then it puts all the data together and put it on a graph.
So for our future work, we wanted to include a couple more sensors to this. One of the sensors being carbon dioxide, so we can measure the levels of carbon dioxide that the plant has. And we also wanted to monitor other additional environmental factors like the quality of the air, ultraviolet rays, humidity.
We would also like to change our device from being run off of Bluetooth to Wi-Fi. Now the benefits of this is Bluetooth, you can only use it in a certain area, which makes it somewhat limited. So we would like to connect it to Wi-Fi, therefore you could view your data and view what the system's running from anywhere in the world. And that is our project.
So this is our self-watering plant project we've been working on. So this first part is the local system with a couple sensors attached to it. So if we take this off, we can see that there's a humidity sensor and temperature, and also the soil moisture sensor that measures the amount of water in the soil. On this side, we got the water level sensor, so it's gonna sit inside of where the water goes, as long as a pump and tube. And then up front, you can see there's a display with 2 LEDs, one for the water level and one for the pump. Our next system is solar that's attached to this solar regulator that we made here at school and fabricated. It's 5 volts that supplies the Arduino. Then in this part, this is our Bluetooth part, which sends us information to our smartphone. So if we open up the app, you can see it receives some information with sound.
Humidity 17.00%, temperature 22.00 degrees Celsius.
And if I plug this in, I can show you how it works. So you hear the pump turn on because there's no water in the soil. So if we add some to it, so the value is going to start to change. And then the pump turns off. And you can see the humidity changed as well.
Humidity 50.00%, temperature 23.00 degrees Celsius. Humidity 61.00%, temperature 24.00 degrees Celsius. Humidity 64.00%, temperature 21.00 degrees Celsius.
Nice. And this sensor I can show you. It's reading as 61%.